Okay, so here's our last lesson of new stuff for a little while, and it's a little bit of an exaggeration to really say this is new stuff. It's basically the same thing we've been doing for the last 2 days, 3 days in a row. What we're working today for homework, what's due today is 1 to 7, so we'll look at that in just a minute. What the next installment is, it's going to go from 8 to 18. It's going to be almost all the same stuff, but they do have one new trick up their sleeve, and number 8 does this. So I'm going to do number 8 for you for free, and then you can just keep rolling up to 18. They're not all like number 8. Some of these are going to be like the ones we've already been doing, okay? But some of these are going to use this like little bit of a new twist that they're doing on number 8. But we're making a table. Across the table, what has our heading been each time?
Rate, time, distance.
Didn't last long in the video. 2 seconds in, we got a dead chalk. But we're going to go rate, then time, then distance. We like that order because what's that let us do? Math-wise with these tables as we fill it in.
Multiply across.
Multiply across. So multiply across is our friend. Rate is always a measurement of how
long or like
how fast it's going. What's a key word in the rates we can skim for in the paragraph?
miles per hour.
Per, which sometimes they do with a slash. So what do you see in number 8 that has rates? It's a how fast, it's got a per or a slash in it.
24 and 30.
24 and 30. So what's different about the 24 than the 30 that we could use some words here to just differentiate these two different kinds of trips that we're taking?
So if you're going
She's going to go,
and back,
and then she's going to come back. What was her going rate?
24,
24. Her back rate
30.
is 30. Question about that? We've done that a good bit. If the rates are numbers, you're pretty much guaranteed that the times are going to be letters, variables. There's got to be something that's unknown. They do the times differently than this time than they ever have before. So something we've done before is they might tell you it's the same time. So if it's the same time, what have we been doing to the boxes?
Just T.
Just put T's in both boxes. Sometimes they'll tell you that like one has gone 2 hours more. And then one of the boxes is T, and the other box is T plus 2. Or maybe it's T minus 2, depending on your feeling of what you want to do with that. They didn't do either of those things this time, and that's why I'm right now presenting number 8 to you as a sample problem. What did they give you with the times?
How long the trip took?
One way, the other way, or total? Total. The total time is 13 and a half hours. So that's not the going time. The going time would be like about half of it. The coming back time, it's not that either. It would be about half of that. But they're not the same. Why aren't they the same times on the 2 parts of the trip? Why can't we just cut this time in half and act like it's the same? The times aren't the same.
Because they're going different speeds.
They're going different speeds. If you drive slower going there, it's going to take you longer. And if you drive faster, it's going to take you less time. So what we're going to have to do is just for a moment, set aside this 13 and a half hours. It's not this time, it's not that time, it's a total time, and we don't have a total thing for our table. We're just going to set aside the 13 and a half hours for now. But recognize this, we don't know what it is. This, we don't know what it is either. Those both have something to do with T's. And the grand total of it is 13 and a half hours. And we're going to have to figure this out. Okay? But we're in a new spot. We've never been in a problem like this before together this year. Anybody want me to try to explain how I know I'm in like a different sort of predicament? So then let me make a simpler problem of this same style, and it's more doable. If I told you that I had 10 cookies, which I don't get excited, there's no cookies. And I said, I'm giving these all to Sam and Kellen. If I gave 3 cookies to Kellen, you could figure out that that means I'm giving 7 to Sam by using like basic math. If I said I had 10 cookies and I'm giving 4 to Kellen, that means I'm giving 6 to Sam. If I tell you there's 10 cookies and I give T to Kellen, how much am I giving to Sam?
You don't know. T.
But I can express it with math. How did you get the 7?
Or the T minus 10.
You did 10 minus 3. How did you get the 6? How are you going to get this? 10 minus 2. The total minus the 1 will make the other. So, simpler stories again. I have 12 cookies. This time it's even Izzy. If Eve gets 4, Izzy gets
6.
8.
8 because
12 minus 4.
12 minus 4 is 8. If Eve gets 2, Izzy gets excited because Izzy gets 10 because
12 minus 2.
12 minus 2. And if there's 12 cookies and I give X to Eve,
12 minus
12 minus X. Do you understand the flow of how that's working? Okay, so what we have is 13 and a half hours. It took T to get there. So it must be taking
13 and a half minus 2.
13 and a half minus T to get back. Anytime they give you the total time, and you have to set aside a total time, make either of your boxes a letter. The other box is going to be total minus letter. So here we did a T, here I did 13.5 minus T. Could I have put the T here instead and made that 13.5 minus T? Yeah, those would be switchable, it doesn't really matter. But we need a T and we need a 13.5 minus T. I'm going to erase all my cookie work. Sorry to tease you, there are no cookies. Maybe some other day. Probably not. Question about setting that up from paragraph? The table setup is a little different some of the time, but then finishing from here is always the same. What do we always do every day to finish every table? Multiply across. So this would be
24T.
24T. This would be a distributing problem, so for now I'll just put 30 wants to distribute, and I'll leave it at that. But finishing the table is always a multiply across move. Question about that? Equation creation is usually the same, I'd say 80% of the time. If we're on a trip and we're going there and we're coming back, what do we know about the distances? You go there, you come back.
Same.
They're the same. So generally, the one distance box is equal to the other distance box. Every once in a while, they'll tell you a different story, and we have to add these up to equal some other number that's in the story. What were those stories always about? What were the cars and stuff doing whenever we had to add their distances up?
Same
Numbers.
time.
They do usually same time stuff, but they usually send them on a certain kind of trip.
They go in opposite ways.
Yeah, they'd start them together in the same spot and then run them away from each other, one going east and one going west, or something like that. But if they ever do that, 20% of the time, the equation is box plus other box equals mystery number. But we don't have another number for this story, so that's where we are with this. Then you solve. Solving can be various difficulty levels. This, you're not probably super excited about 30 times 13 and a half. Can somebody get that?
305.
It is 405. Then what?
Did you add 30?
Add the 30. We need all the t's to the same side, so doing an opposite. Adding 30 gets us up to 54t. It's 405. Then
Divide.
So 405 divided by 54. I'm not real excited about the idea of long division, so maybe let's think if we can reduce that at all. Can anybody think of any number that goes into both of those?
3.
3. Good old 3 trick from 7th grade. If you add the digits up to 9 and add the digits up to 9, that means 3 could go in. If we go 3 in, we'd be 135 and 18. Can anybody go into those?
3.
3. Go again, so we're 45 and 6. Can anybody go into those?
3.
3. So we're at 15 and 2. And I feel pretty good about dividing 2 into 15. 2 into 15 is
7.5.
7.5. Maybe I shouldn't have circled that. It's maybe not the answer and be all done, but we needed that. Question about this all opposites. Now we've got to see what they asked. If they asked us, well, what does the t represent? Time for what? Time to go, time to come back, time total. What's the t?
Total?
Distance.
That's a time.
The time back.
Time
For
2.
each part.
That's the time to go. Since the t is in the line in the chart of going, the t is the time to go. So 7.5 is the time it takes to go. If they ask us, and I'll look at the paragraph in a minute, if they ask us how long does it take to go, the answer is 7.5. What if they ask you how long does it take to get back? Well, that would be the back line, the time box. If you solved and algebra got you a time, a t, a 7.5, then how much is the time to get back?
6.
6. Because it's 13.5 minus the 1 makes the other. These two need to total 13.5. At the very beginning, I started off saying these times shouldn't be the same. The slower car should take more time. The faster car should take less time. They're probably both kind of close to half of 13. You know, half of 13, you're like 6 or 7. You know, they should be like 6 or 7. But this one's 6, that one's 7. So if they ask how long, maybe one of those times is the answers. But maybe they want a distance. If they want the distance, what would they ask? How far? So if we want to do a how far, you'd either have to do 24 times 7.5, or you'd have to do some bigger math here that maybe you don't really want to do. I don't know. But we already, maybe we wouldn't mind that, because we already did the subtraction. So the subtraction got us 6. Maybe it's easier to go 6 times 30 than 7.5 times 24. But what do we know about the distances that we already said 5-10 minutes ago? They're the same. So whether you do 30 times 6 to get 180, or whether you do 7.5 times 24 to get 180, it's going to get you 180. If they wanted to be jerks, they could ask you for the total distance on the car for the whole trip. What would be the total distance for the entire trip for the whole car?
360?
360, because 2 180s could get us up to 360. They could ask any of that. It's up to them. They wrote a book. They asked, what's the distance one way? So which of those circled numbers is the answer for distance one way?
180.
180 is what they wanted. But they could have asked for any of that. Question about 8. Okay, so here's our schedule of events in our near future. Today's homework, I already said we're going to continue on 176, working from 8 to 18. Tomorrow on this present calendar is Friday, and it's also the day the grade period ends. So if you owe me any homework, that needs to come in tomorrow. People watching the video some other year than 2024, maybe your calendar's a little different, but the grade period end is probably pretty near with whatever year you'd be watching this thing. On Monday, no, tomorrow's Friday. Tomorrow I'll give you a review sheet, or I'll give it to you today if you want to work ahead. But there'll be a review sheet due on Monday that covers like all of these last couple days worth of problems, and there'll be a quiz like early in the week, next week someday. Question about schedule upcoming. Well, we shut that down.